Greetings and salutations. Thank you for checking out the video. Today we're going to talk about something that is near and dear to my heart. We're going to talk about text files in Linux. Text files are awesome, and I'm going to show you why they are. We're going to start out with the most basic tools. We're going to talk about what a file is, and by the end of the video you'll be writing a script. So, if you like this video, give it a like. That helps to get videos like this out in front of more viewers on YouTube because it lets them know that you like this sort of thing and other people might like it as well. If you are not currently subscribed to the channel, consider doing so. It helps me, it helps the channel, and it helps build a bigger community around what we're talking about here, which is Linux. Thank you to everybody who has subscribed in the last month. We've had an avalanche of subscribers. Thank you very much. So we got a lot to cover. Let's jump right into it. We're going to start out with the very basics today, and we need to define what a file is. That's nothing more than a collection of named data that you store somewhere on a storage device. And that file could contain anything. It could contain the data that makes up a picture, or a song that you want to listen to, or a video that you want to watch, or a document that you wrote. There's all kinds of different ways of arranging ones and zeros to represent things that are useful to us. Today we're concerning ourselves with text files. A text file contains nothing but plain UTF-8 ASCII characters. Now, what does that mean? UTF-8 is usually the standard character set that we use in Unix and Linux these days. And that contains the ASCII character set. UTF-8 adds to that. ASCII is the most basic set of characters. It's 256. It's letters, numbers, and pretty much everything you see on your keyboard can be represented with ASCII. What is really cool about a text file is that you can look at it and you can tell how many characters are in it, because a character is 8 bits, 1 byte. It used to be 7 years and years ago. It was considered to be just 7 characters. We didn't count the 0. That was back in the days of teletypes and baud rates. But sometime in the 80s, they decided we needed to count that 0. That gives you the ability to do more unique patterns, see? And a unique pattern of 1s and 0s in an 8-character little word there can represent all the characters that we use on our keyboard. And since everything is 8 bytes, all you have to do is look at the size of the file and divide it by bytes, and you know how many characters are in it. A very compact way of storing things, even though we do have things like zip and GZ that actually can make it smaller. A zipped file, for instance, they use different algorithms to figure out patterns and that sort of thing. That's way above our pay grade. We're not talking about that today. We're talking about plain text. We're not going there. Okay, a directory is nothing more than a file that contains the names of other files. That's it. That's all it does. As a matter of fact, on Unix and Linux, your file name lives in the directory. It's not in the file itself. It's in the directory that it's stored in. So this is why the root directory does not have a name. It's just represented by a slash. There is no directory above it to store its name, so therefore that directory is nameless, which makes it root. It's actually quite simple when you get into this. It's not as difficult as people think it is. So the next thing that we need to touch on here is file permissions, because they are very important in Unix and Linux. And this is how we keep our systems secure. There is the notion in Linux and Unix, it's interchangeable because, of course, Linux is a Unix-like operating system, so let's just say Linux from now on. And there is this notion that everything on the system is a file. Everything on the system is a file. Your hard drive is represented as a file. Your keyboard is represented as a file. Everything that data can either be sent to or taken from is a file. And those files are owned by somebody. Now, that somebody could be the root user, which would mean the system itself in a lot of cases, or it could mean anybody with elevated privileges, or it could be individual users. They can own a file as well. These permissions are simple but rigid, and they can trip people up, and not just people who are novices, not just people who don't know the system yet. No, I have worked with a number of engineers through the years, and we'd be trying to figure out what a problem is, and these are people that are way smarter than me, and we finally realized, oh, it's a permissions thing. We didn't even think of that. So that happened to me just the other day. I was trying to transfer some data to a friend of mine who is holding some data on a server for me, and we couldn't get it to work, and it's a permissions issue. Duh, we figured it out finally. So let us open a terminal, and we're going to use ls with the long option to see all the files in the home directory here. And we have a couple of files here. This is where these text files are where I was experimenting with certain things. And then we have a bunch of directories, basically. That's what the file system is. And over here, all of this gobbledygook here are the file identifier and the permissions. This tells you whether you're looking at a directory or a link or a file, and what the permissions are. So if we look here, the file type here is a directory, but it could be a link, and a link is nothing more than just a little blurb of a file that sends us somewhere else in the file system. You can link another directory, or you can link another file, and that can be quite useful. And then we have the permissions themselves, and they are represented in this group of characters here. There are 9 characters total with 3 groups of 3. The first one represents the owner of the file, and that could be the root user, or it could be a file that you own yourself. The next 3 represents the group permissions. And if you are a member of the group that owns that file, you have access to it. This is how in the early days of mainframes that different individual project groups within a corporation or a school could have access to files on a big machine, and everybody could work on them, but they were still owned by somebody. You would set the group permissions. Groups these days in Linux are mainly used to set permissions for users on how to access certain parts of the system. It works the same way. Remember, everything's a file. So if we set permissions on the mouse, you could actually make it so that Bob, who is a user on the system, can no longer use the mouse because he was doing something weird with it. Now, the mind reels, but anyway, the last group of 3 here is the world, or other. This is anybody that can gain access to the file. So we can express it this way, or we can use Octal, which is numbers, and we're going to get into that in just a moment. Because Octal is the way I like to think of permissions. My brain can process this a lot easier than any other way. And I think this is actually the easiest way to learn once you wrap your brain around it. So with Octal permissions, we're using 8 characters, 0 through 7. Now in a past video, I had said that bytes used to be 7 bits, and so therefore you can think of it as a byte. You still can. Of course, all of the pedantic people went crazy because I didn't explain in there that back in the old days of teletypes and baud, it used to actually be 7 bits was a byte and all that. And so they went nuts, and they said, well, no, it's 8, you're an idiot, it's 8 bits. And the other thing they did was to explain to me that the actual storage of the permissions is not done with 8 bytes at all, it's done with 3. Yeah, I know. Messes with my head too. But we're going to just use the byte here as our way of understanding this. And if we have everything adding up to 7, that means we have the permission set to read, write, and execute, with read equaling 4, write equaling 2, and 1 equaling execute. So if we use change mode, CHMOD, which is the command that we can change permissions in the terminal. We can change the permissions very quickly just by using the numbers. So in this case, if we do change mode and then we do 755 in the file name for any given user, whoever owns this file, then we can very quickly set the permissions to be read, write, and execute, which means that you can read it, you can write it, and run it as a program, and then we can, everybody else, the group and the world, can just read it and execute it. They can't write to it. So that's how that works. Of course, you can do all of that point and click, too, in the file manager. There's another way to set execute, which might be easier to remember because most of the time when your average user is going to be fooling around with the permissions on a file, what they're going to do is just make it executable. They've written a script and they would like to make the system be able to execute that file. And that is how you would do that. You would just do change mod and then +X and then file name. And what that does is it makes it just universally executable without changing the original permissions. You can also change permissions using letters with change mode, and I never can remember how to do that, so I don't even bother. And then down here there's some language about permissions with directories, which is a completely different ball game, and I'm not going to get into trying to explain that, but if you would like, you can pause the video and read that, and you can pick up more about it. One of the takeaways that may have occurred to you from all of this information is that the system basically doesn't care what's in a file, and that's true. So Linux will happily try and execute your MP3 file of your favorite song if you make it executable. It won't work, of course, because it's not really a program. But you can also use a plain text editor to read what's in a program. And that means that you can find executable text in files where you, or readable text rather, not executable, text in files that you wouldn't expect to be able to see it. And a lot of the programs that are on your system in your, /usr/bin folder, for instance, they're just text files. They're written in some sort of scripting language, okay? And those files are humanly readable, even if you don't understand the language. Let's say that you just want to change a word that appears on the screen. Somebody misspelled something. You can go through there and see if you can find that string of text, and you can change it and save it and run it and see if that fixes it. It may break the program, it might not. But it's your system. Have fun. Do whatever you want with it. One more thing to take away from this is the fact that we don't need file extensions in Linux. File extensions are there for users. We like to have an extension that says to us, oh, this is a document, or this is a music file, or this is a picture. PNG, MP3, ODT, docx, whatever. The system doesn't need it. It already knows what kind of file it is. It's figured that out when it has listed the directory. And that is why the programs that run on Linux do not have any exe extension or a com extension. They don't need it. So if you look in your, once again, the usr/bin directory, you're going to see that most of the programs just have names. System doesn't need it. So here we are at a terminal, now that we understand what we're dealing with and working with files and what a directory is and all that stuff. Let's start creating files. Now, I have a couple of files that I was playing with earlier that already exist in our directory here, so I want to go ahead and just get rid of those so we can start over. So let's go ahead and get rid of a couple of files. So before we create a file, I'll show you how to remove them. We're going to get rid of folded, and we're going to get rid of test, because we're going to recreate those. So let's go ahead and clear the screen. It's super easy to do. Control L, or type in the word clear, and hit enter. So to create a file, the simplest tool to do so is a program called Touch. And touch will create an empty file. Basically, it'll put a file name in a directory for us. There is no data associated with this file yet. It is just a file name. This is very useful, by the way, in scripting. When you want to indicate somewhere that you've done something, you will create what's known as a flag file. A flag file is simply a file that exists to either show a user or another program that something was accomplished. It's easier than a log file where you add things to a text file. We'll get into that shortly. So when you touch a file, we're going to touch text.txt. And we're going to list it. And yes, our file showed up. Oh, forgot to get rid of sorted too. We'll get there. We need to do that correctly if we're going to make it work. There we go. But our file is there. That's what we wanted to see. See, I should have cleaned up before I started the video, but you know how things are. Life happens between doing the research and creating the video, and sometimes you forget these little things. Anyway, we have created a file, and it is called text. And if we ls with the long option, you can see that our file contains no data right here, and then it shows that we've created it today, October the 3rd, and we created it at 12:20. So touch has another interesting thing that it can do. It can change the modified date of a file. So if we go back here and we touch this file again, watch what's going to happen when we list it again. Well, now see, it's 12:21 because I talked about a minute. So that's what touch does. Very basic little thing. We've created a file. We don't need to do that to usually create files because programs will create files. But sometimes it's nice to have your files there already. It helps you to figure out what you're doing. And we're doing this to illustrate a point here. Touch a file to create a file. And type that properly if you're going to do it that way. So, we know how to touch a file. What about creating a text file? What is the absolute simplest way to create a text file? Well, we can create a one-line text file with echo. So we use echo and we put in quotes. This is one line. I'm going to make that proper. And then we will use the angled bracket. That's what these are called. To put it into a file, and in this case we're going to use our file that we've already created called test. If we had not created this file, whatever file name we would put after that would be created. So, like I said, we don't have to touch it, but I wanted to show you that anyway. So let's go ahead and do that. We got no output, so apparently it works. So how are we going to read our file? Well, we've got several options for reading files, and we're going to take a look at those, but we're going to use the simplest, which is called cat. Okay, and cat, if we feed it a file name, will just take the text and print it on the screen. Or you can also send the output of cat into a program, or you can send it into another file. Cat does not care. It just takes text and puts it all together. And it's short for concatenate, which means we can take a lot of short files and make a long file. So there is our file with one line. And if we wanted to add a line to that file, we can use echo once again. Very brave people who like to edit configuration files this way, where they need to add a line of text to the bottom, will actually do this. In other words, just blindly they will create a line of text and send it off to a configuration file, and it should magically appear at the bottom. So we want to learn how to append here. And to do that, we're just going to put in, this is another line. Okay. And this time we're going to use two angled brackets. 1, 2. And we're going to give it the same file name. And what that does when we use two of them is it explains to the system, the command line interpreter, what we want to do with this data is append it to the file that we've already created. So let's cat that file once again. and you'll see now we have an extra line. So you could write a pretty big file one line at a time if you wanted to, but that might get a little boring. So what we'd like to do next is maybe use a slightly more sophisticated tool so we can write more than one line at a time. What do you think? Now this is one that I just did not too long ago in my video about all of the super cool Linux commands. This always blows people's mind. If you haven't seen that video, you're going to like it. So we're going to use simple old cat again, which, like I said, is a program that just takes input from somewhere and outputs it somewhere else. And we are going to create another file. And we're going to send this one into test2. I want 2 different files. And I'm only putting .txt on here for us. We don't have to do this. The system doesn't need to see txt to work with text files, but it makes it easier when I go look at this later and go, where'd that come from? Oh, I did that for that video. So with the cat command, when we hit enter to fire it off, you notice it just sits and waits for us. It's waiting for us to provide input to the program. And so we're going to do one line at a time. Now, arrow keys don't work, so I can't go back. You see, we get these funny characters. Those funny characters are the actual characters that represent the arrow keys. Those are the UTF-8 characters that represent those keys. Ordinarily, we don't see them because the terminal, what it does is it says, oh, that character means I should move the cursor. It interprets it for us. But since we're writing plain text, it takes everything that we type at face value. So go ahead and hit enter, and I can move on to a new line. And I just keep going here. And then you get the idea. So now when I'm done, I hit D, Control D, and what that does is it tells the program, I'm done feeding data to you, now do something with it. So it should have sent it into that file, and of course we can look at that very easily with cat. So we're going to look at test2. Oop, hold on, what are you doing? There we go. I was trying to hit the tab key and ended up hitting something else. Anyway, so now we see our file. Now the concatenate command will put those together for us. So if we do cat again, and then we do our 2 files, test, and of course it's wondering which file I want. There we go, test2, and I put those 2 files together like that. When it displays them on the screen, we have both of those files being displayed together, one after another. That's concatenate, and that's what it does. The cat command is very cool and extremely useful. So let's look at a couple of things that we can use to read commands. And we're going to get into pagers now. Because cat is cool and all that, but if we try and look at a long file with cat, look what happens. So if I use cat, and then I go documents, and let's look at a speech I have from Edward R. Murrow that I've got, it's a transcript, right? Let's see what it looks like. Well, it just scrolled up. Of course, we could scroll down, but that's a lot of text. I mean, that's a lot to deal with, right? And it's kind of running off the screen. It doesn't look right. So maybe we want to use a different way of doing this, and there's a couple to read files. So this is for plain text. So let's go ahead and clear our screen. And we're going to use more first. More is a very simple and very old pager. And we're just going to feed it a file name once again. And we're going to give it that same speech to work with. We'll be using this file a lot through here. Right? And now it's a little bit easier to read. It's more logical. And we can go through here and we can read what the text on the screen. And then we can hit space, and we can just page through that. We can't go back up, well, we can scroll up, but the program itself basically just pages through. Right? And when it gets down to the end of a file, this is a lot of pages here, then it just dumps out. So that's one way to do that. A more advanced program is less. That's right, less is more than more. We'll do the same file again, documents, Word. Now we can move up and down, and we can do like one line at a time. See, I'm moving up and down using the arrows. The space bar will give us pages. We can go back up. There's all kinds of options with less. Now when we get down to the bottom of our file, let's just page all the way down here, you're going to see that we don't exit the program. We still can we can scroll back up and look at something else. So less will actually keep control of the shell while it's running and not just dump out when it's done. To get out of less, you just hit Q, and it puts us back on the main screen. So those are ways to read files without actually opening up an editor. Now, let us look at a couple of scenarios here. We've already seen one where our text was not rendering right on the screen because apparently it's like one long line. This will make sense later. We also might want to sort what we see on the screen. We might want to create a sorted list of something. So a lot of files have lists in them. You'll be creating lists, and you might want to sort them. So let's go ahead and do that. We'll use cat again because it's fun. And we're going to go ahead and put this into test 1. Or test file. I just test 1. Probably should have named it test 1, shouldn't I? See, my brain is working on that logic, but I didn't name it that way. So we're going to create another file here, and we're going to put names in it. Just random names. And look, I can't change that. See how it's CI with a capital I? I made that mistake. I can't fix it because I hit enter. So we have to live with that the way it is. Let's do Cindy with a lowercase because this will illustrate something. And I did that with Wolfgang, but I can catch it this time with the backspace key. Let's see. We need another name here. A couple more. I don't know. There you go. Bunch of names. And we're going to put that in a file. Control D saves it. And because we only used one greater than or angled bracket there, we're going to replace what's in there. So now what we want to do is sort it. So let's sort that file. And we're just going to execute the sort command. And we are going to put that into another file. We've got to put our file name in. All right. So we're feeding this to sort. And then we're going to put this into a file called sorted. And we're going to put an O in there because it makes more sense that way. And let's do it. No output means it worked. Let's look at what's in that file. We'll use cat, and we're going to look at sorted. Now everything's in order. Notice here that Cindy with a capital I is sorted after the lowercase. So the lowercase is sorted first. Now that is a little bit contrary to what Linux usually does, let's say when it lists a directory, because it'll sort that automatically too. But capitals usually are sorted before lowercase. In this case, it's more traditional. And you see that the uppercase is sorted. Very useful little tool. Sort can also be used to sort in columns. So if you have a database file, a delineated database file that's delineated by tabs or columns, you can put the column number in there if you can figure that out, and you can get it to ignore the number of spaces between that, and it will actually sort by columns. So let's say that you had names and numbers next to each other. You could do that. And what I meant before here is that the lowercase I is coming before the uppercase I. So that is sorted in that order, whereas the system usually does that the other way around. But this, I guess, is more traditional for working with text. Just something I happened to notice there. So we've got some pretty basic little commands here. Let's start looking at editors themselves. And of course, when you're dealing with very small files, cat will do the trick, and you can add lines to the end of a file, all that kind of stuff. But really, you probably want a more advanced editor to do all this stuff, right? The most basic editor that you will find on every Unix and Linux system that you sit down in front of is one of the most despised and or loved text editors in the history of computing. Some of you already know what we're going to talk about. We're going to talk about VI, sometimes called Vim these days because the package is actually now called Vim for VI improved. Some people call this Vi. I'm not going to get into that argument. I've always called it VI. And we're going to let it look at our test2 file just to get an idea of what it looks like. So VI and the name of the file. Here we go. And one of the weird things about VI is that it is not as intuitive as like most of the text editing stuff that you're probably used to working with. VI is very old, and it uses a very weird way of navigating and inserting text. You're in two modes. You are either in insert mode, which is what it comes up in, or you're in command mode. And command mode is where you can do certain things. I don't use VI. I don't like VI. I am ignorant when it comes to VI. If I had to use VI on a system that didn't have anything else, like some sort of embedded device that didn't really have a real command line environment, and you only had like BusyBox and the only thing you have is VI, I could probably get away with making it work, but I would not choose to edit anything in here because I'll give you an example. Like, okay, the arrow keys do what you think they're going to do, right? So now, let's say that I want to change this to something else, and I hit backspace. Well, that means nothing. It doesn't do anything. So I have to use delete, and like the delete key will do it, right? But now that I have deleted this, I can't. It doesn't work the way you think it is. I started typing, and apparently I can't just like put that back in. See what I mean? I don't understand that. You have now reached the level of my incompetence when it comes to VI. I know nothing more about it than this. If you want to learn how to use it, there are guides online. I will say this. Many years ago, I actually posted a video on how to use VI. I did not produce the video. My friend Jeremy O'Connell produced it. And he was a guest host because he knows how to use this. And he is an engineer who actually likes using this thing. I know, he's a sadist, right? But anyway, I posted the video, and it had the worst views of any Linux video I've ever posted. Nobody watched it. I felt bad for Jeremy, man. But feel free to go learn VI if you want to. Now, one thing I do know how to do with VI is get out of it. So you are in insert mode right now, which is where you can put text in. If I hit escape, all right, and then hit a colon, you notice that appears down here on the very lower left-hand side of the screen, and it's waiting for me to give it a command. So the command that we're going to give it is the Q command. That should be lowercase q. and an exclamation point. Now, what that tells the system is that I'm done, I want to get out of here, and I don't want to save changes. You could type in WQ, which means write and quit, or you can just type in X. X will write and quit as well from VI, and that's what we're going to do right now. Bye-bye, VI. When I am in a terminal and I need to use a text editor, the one that I usually go after is Nano. And so we are going to open up Nano, and we'll look at the same file. And this is way more intuitive. You can use your arrow keys. Your backspace key does what you think it should. I can type in enough. I can, well, you can spell it properly, or you can just get rid of it. See, I can move around. I can add text. This is pretty much just the stuff that you think it should be. I can use the arrow keys to go down, use return to add another line, that sort of stuff. Nano is extremely powerful, even if it runs in a terminal. You can do a lot with it. You can even spell check things with Nano. It's very cool. So when you're done with Nano, when you're making your simple changes like we just made, there's a couple of ways to get out of it. You can just hit Control Save, and that will save your work right there, and it shows you what's saved. We saved back into the file we were working on. Or if we want to create another file or create a file name, then Control O, and then you would put your file name here, and you could also put, you change your file name, like, let's, for instance, if we wanted to make a backup of this file, we could call that old, and now we'll end up with a file there like that. Yes, and so just hit the Y, and it's done. So we have created a backup. You could do that first, then do your edits, and then save it, and that way you would be in a much better place to be. We're going to come back to Nano in just a second, but I want to show you how to get out of it, and that is Control X. And so now let me show you a downside to Nano, something I don't like about it. Now, I'm sure that there is an argument that you could use with Nano that would make this do this automatically, but as you usually run into it, it doesn't. So we're going to do Nano, and we're going to go back to that speech that we were looking at. Good old Edward R. Murrow talking to the Radio and Television News Directors Association in 1958. That's what that is. Well, what is this craziness? Well, this file is not formatted all that well. You'll notice that every paragraph is just one long line, and they just go off the screen. Like I said, there's probably a way to wrap this. I would not ordinarily be reading something like this in Nano. It works better for working on files that you are using to, configuration files or scripts where you're going to keep it at 80 columns or whatever. But this will also illustrate another feature that you can turn on here, which is pretty cool. So I'm going to go ahead and exit this again, and we'll get this command back. And now we're going to do Nano, and we're going to do the L option. Now we get line numbers. Now when you're working with scripts, writing programs, this is very useful to have a line number. So you can do that. But still, this doesn't make it any more readable, does it? No, it doesn't. So let me show you another little tool. We can fix this. We can make this file much more easy to deal with. And we're going to exit. And what we're going to do is we're going to use the fold command to come up with a version of this. We're going to do fold, not folded. And we want, just so it will appear on the screen, we're going to do 70 columns. And that should be not a equals, but a dash. 70 columns. And then we're going to say we want it to break its spaces. And we're going to feed it this file name. have to tell it where it is too. In the system, so Documents, Edward, and then we're going to send this to a new file. We're going to call folded.txt. Now, if we open Nano, and we can count the lines if you want to, and we're going to grab our folded file. Oh, look, this became a lot easier to read. So that's what fold does. Fold is very useful when you need to format a file to be readable in some sort of situation where you are not going to have automatic word wrap. This is very good when you're placing here documents and scripts. A here document is like a help page or any kind of text that you want to put in a program. You probably want it to be less than 80 columns. Now, I have done a 70 column here, and I've told it that it can break at a space, and you'll notice that sometimes it runs over a little bit. Very cool indeed. So those are the basic terminal tools. You do realize that other than VI and Nano, we haven't opened up any real editors yet. We're not doing anything graphically. So let's take a couple of moments and look at the graphic editors that are available on this system. And there's a lot of editors on a computer. Believe it or not. This machine has like 5 or 6 installed, and I installed 2 of them to show you guys. So one of my favorite editors to work with on a lot of systems, like a Debian system or an Ubuntu system, is gedit. Gedit is old school. It's been evolved through the years, and gedit is very powerful. And I took a gedit instance and I really just decked it out so we can see what it does here. So let's open up gedit. And I want to look at a configuration file. We'll look at a text file in it too, but we'll look at a configuration file. And we are going to do, let's do etc fstab. This is the file where the system uses to load file systems. We just talked about this in the last couple of videos when we were working with swaps. So this is pretty cool. So let's open this up. And I'm going to end my command here with an ampersand. And the reason why I'm doing that is so we have access to our terminal even when the graphic application is running. We're putting it in the background is what we're doing here. Multitasking in a terminal. Yes, you can do this. So here's our here's it running. And I have this set up. This would be the best way to do it if you were using this to actually write code in a script, like a bash script or any code. You'll see that it not only recognizes the comments here and colorizes them in such a way, but it's highlighting the line we're working on. I have it where it shows where 80 columns is, so if you're writing a command, you can use the exception character to tell the system don't return, consider this another line. I'll show you that shortly. And so this is, for quick and dirty editing, gedit is pretty awesome. And it doesn't come installed by default with Ubuntu anymore, and maybe not on Debian 13 either, because the GNOME project seems to have moved on from it, and they have a new thing that they're using, which is actually not a bad text editor, and I don't mind using it. I'll show you that one. So this one is the gnome-text-editor. Gnome-text-editor. So that's a lot to type, isn't it? Now, I can autofill, but still. gedit was short, so I'm already not liking this because you've made a longer name for the program. It's very similar, but I can't get my Cobalt theme in there, and I like that best. It's not on the gnome-text-editor. And there are a few features that are different. But anyway, let's take a look at Edward R. Murrow again in here. And this time I'm going to look at the original, not the one we folded. Because one of the things that this will do is automatically word wrap. And it does a pretty good job of it, too. And let's see, it's got some other, that's some file I was working on earlier before the video. It will remember what files you're working on. It'll hang on to them and open them up in a tab. By default, you can resize the text, which is something that I really like, and you can make it unbelievably huge, which is very good. I actually, when I was doing radio stuff, used to use this program for a while as a teleprompter because it was so easy to use. If we go over here, I've installed the plugin on gedit that allows me to do the same thing. Let's go ahead and open up some sort of a script file so that we can see what we're doing here. And in the new tab, I opened a new tab, and now we're going to open up, let's go ahead and I guess we just search for it. So I'm looking for bin/show because we're going to talk about that program later on, and it's a script, and there we go. Let's open that up. And did it find it? Yes. Well, no, it did not. I'm so confused. What did I do wrong? It's because you're dumb. Okay, this searches this stuff. Searches the history, you idiot. I'm kind of new to this program. Don't judge me too harshly. Let's go over here. Let's open that back up so I can get to it. Thank you. I just minimized it. There we go. Let's see. Where is open? All I want to do is open a file. I don't understand. Why is this so hard? I'm going to click over here. Okay. We'll do it that way. Wah. I don't like changes in my cage, folks. This doesn't... See, it's like... It's one of my big criticisms with GNOME is that they change stuff, the flow, the workflow of things, and I don't know what they're thinking. And then you have to figure it out. You know, it's like, oh, and sometimes it's better, sometimes it's not. All right, I want to open this program so we can take a look at it. This particular script. So you'll see here that when you have code of some sort, that it does colorize it. It makes it easier to figure out what you're looking at. I prefer Cobalt. Now, this should be easier here, right? If I go to open, look, isn't that cool? It opened up a file manager window. Now I can find the program I want to open. This is the way it ought to be. Don't make it complicated, guys. Jeez. Okay. I'm over it. Let's go to show. I like the Cobalt way of doing this. I just like the colors. It really pops for me. So these are like real text editors that you would use to write code, but you could also use them just to read text or to create plain text files. When you set up your fonts, all right, for these editors, you have to make sure that I particularly like to have monospace fonts because, like in the beginning when I was showing you that thing where we were, I had the ASCII art. If you don't have a monospace font chosen, then that doesn't render right and stuff like that doesn't look right. It would look right in a terminal, of course, but it doesn't look right in a graphic editor when you're not using a monospace font. And you can go over here to Preferences, and you can change that. And it works the same way in both programs. These are the schemes, the color schemes that you can choose. Cobalt is not here. You could probably import it, but anyway. So that is a look at text editing and text editors. So what I would like to do is back up the truck a little bit and get out of here. Go ahead and close these up. And take a few minutes at the end of the video to show you something useful that you can do with all of this stuff that I just showed you. We talked about how we can create files that the system will execute as programs. Those are scripts. And the simplest script to do is a bash script. A bash script will do something simple. So let's create a small bash script. And we can do this, as I said, in a complicated text editor, or we can do this with cat. So let's go back to doing it with cat. So what do we want our script to do? We'll just call it okay. When you have a script that is not in a place on the system where we would usually execute commands. In other words, this thing is going to be stored in your home directory or just floating around or something you're going to send to your friend. You usually give it an sh at the end, which means it's a shell script. So we're going to do that here. And I think what we're going to do is have it display something on the screen and create a file. It's the easiest thing to do, right? So any commands that you could think of, we can put in a script. So the first thing we need to do is a shebang. And I like to use the traditional shebang format. There's going to be somebody who comes in the comments and says, well, you can do it this way or you can do it that way. This is the most portable way of doing that. So the first thing we're going to do is a pound. Some people call it a hashtag. I do not. And we have a exclamation point, and that's a bang. So this is called a shebang. And then we're going to tell it what interpreter we need to use. In this case, we're just going to use good old bash because we're running bash in this terminal. That is our shell. If you were writing code for Python, then you would call Python. If you were writing Perl, you would call Perl. Any number of languages like that. So line 1 has to be a shebang. Line 2, in this case, is going to be a comment. And to write a comment, we just use yet another pound, and then we can say what we're doing here. A script to show how to write a script. So there you go. That's our comment. And usually I put blank lines between these, but we're using cat, so we won't need to do that. Or we can just go ahead and do that. There we go. Because this is how I do it. I like to put a lot of space in my scripts. It makes it easier to read. If you pile things one on top of each other, then you have a problem. So the first thing that we want to do is we'll have it echo something on the screen. We'll use the echo command. Echo commands are usually self-explanatory, and you don't need a comment in front of them to say what they are. So write a file to the drive, I guess, would be something, you know. So we have that. And now we'll put another comment in. And our comment's going to be create a file. And now we're going to use the touch command to create a file called, I don't know, what do you want to call it? You can call your file whatever you want to. I'm going to call mine script. And we can put spaces. You just have to use this character right there is the exception character. It's just the backslash. And basically what that tells the system is don't worry about the space I'm going to put in here. And when you do file names or anything with spaces, you have to have those. So we're going to touch a file called script it. Get it right, Joe. And we're going to so that's what our file is going to be called. And we're going to echo again. Like I said, usually with an echo, you don't need to have a comment in front of it to explain what you're doing. When you write scripts, you need to put lots of comments in them for every command that you put in there. And the reason why is because if you come back to it 6 months later, you might not understand what you did there. All right? So if you have a comment that explains what you're doing, that's going to help you to understand the logic that you were following when you made the script. So in this case, we're just going to echo something like and then you can also have the option of exiting the script. You can put exit at the end if you want to. It's not necessary. Exit is usually used just as a graceful way to get out of a script. But after echo, it should automatically exit. Exit can be used when you want to set an error code. That's a little bit above what we're doing here. We're doing something that's a very simple script. And so we can just not really worry about that for the moment. We're just going to put exit in there, and that's a good way to get out and also let you know that you're done with your script. So that's it. And once we have written what we want, it says I called it hello because I was going to put hello world in it, but I didn't. You'll get the idea anyway, right? Like the old hello world script, which is usually the way that all scripting starts. It doesn't matter. So let's go ahead and Control D. We wrote that out, and it's telling us that gedit closed in the background. And now we have our script, which is called hello. And since I didn't put hello in it, let's rename it. So we're going to use move. We use the move command to rename things. We're going to call this, we want to rename hello. And the new one, we're going to call it just, I don't know, script. And .sh. Makes more sense this way anyway. Make sure it's there. Yep, it did what it was supposed to do. And now we need to make that executable. Remember, there's a couple of ways to do that. We could do 755, or we could do just the plus key and an X. That's what we'll do. We're going to do plus and an X, and then we tell it what file we're going after, which is going to be script, and that becomes executable. If we do a list on that, and we specifically list the file, just that file, we can get the information, and we can see that we have an executable file. So to see if that runs, what we'll do is run it from the current directory. And you do that by indicating the current directory, which is abbreviated with a period. And then we use a slash to say we want to run this script from right here. You see, if we do not put it in a place which is in our executable path, it's not automatically going to find it. So we're going to manually show it where it is. Well, it looks like it ran, and we can just run ls to see if it created our flag file. There it is. So that is the simplest script that I can think of that actually does something. But any command that you can type into a terminal usually can be scripted. You have to kind of think it through. You have to make sure that you use absolute paths in scripts. So, like if you wanted it to open up a document to work with, let's say that we were going to have the script grab something out of our documents folder here. It is really a good idea to give it the entire file name, like this. So a tilde is an abbreviation for your home directory. And then we have documents. So we're going to do tilde slash, I think this is how it works. It's not allowing me to autofill, which is making me wonder what's going on here. There we go. Documents See, I don't have to type the whole thing. I can just hit tab and it autofills if it can find it somewhere in the system. And we want to have an absolute path. We want to make sure that we know where it is. You might even want to expand that out to something like this in your script. So if it was looking for a file, right, we would do it that way. Now the reason why is because if you end up launching your script from another directory, so let's go cd work. All right, I'll type it properly. We go here like this, and then we try and run our command where we say cat documents, and then we put that file name in there, which is not going to autofill because it can't find it. It's not going to work. It doesn't know what we're talking about. So if we run our script from this, we want it to make sure that it knows where it's going. Does it make sense? I hope that makes sense. You have to have an absolute path. Very quickly here, I'll show you where executable stuff goes. So once you create your script, what I like to do is to create a bin directory in my home directory. So if I go back up one and I go here and we'll just go into bin, you'll notice that I have a lot of scripts in here, including show, which is the script that we used to show the beginning of this video. I'm going to go through that real quick for you too, because it's an example of a more complicated type script. And what you do is you create your own local bin, and then the next time that you log in, the system will find it and it will add it to your executable path. To see your executable path, we do echo and we do path. And this is going to show the variables. So the $, and then capital path is where the system is storing the executable path for your current shell. And you notice the very first thing is home Joe Ben. So whatever I put in there, when I type that, it's going to execute it. Even if there's another version over here, let's say there's another version in user local bin, it's going to do my local one first because it's the first thing in the path. So once you're through with a script, create a bin directory, throw it in there, and it's always available for you to use. If you write a script that you want everybody on the entire system to use, then you would put it in USR local bin. Everything else listed here is for programs that are installed automatically. So it's not good practice to write a script and throw it into user bin, for instance, where all of your binaries from your big programs live. Now, before we wrap this up, let's take a look at the show program, because I said we were going to do that. And we're going to, let's see, what should we use? Let's use the gnome-text-editor. No, I like the coloring better in gedit, that's right. By the way, in Linux Mint, my favorite text editor is edX, which is the standard one that comes with Linux Mint. It is just a fantastic editor. It combines the best of a lot of editors in one place. And of course, there are way more editors out there, gang. You want to play with editors. You want to get into that. That's a deep rabbit hole to dive down into. And anyway. So let's talk about this program that I used at the very beginning to show you text files. And we are using, let's go ahead and full screen that. We'll make it real big for everybody to see. So show takes text files and displays them on the screen, one after another. And what it does is, first it gets rid of the cursor. That's what this does. Hides the cursor. And then it does 3 echoes in a row to make 3 blank lines at the top of the screen. gets the number of columns of the current running terminal, because that changes depending on the size of the window. And it puts that into a variable here called tput columns. Well, that's the output. We're going to put it into a variable called cols right there. And now we're going to use the fold command, which we looked at, and it's going to fold to this number of columns, and then it's going to fold its spaces, which is what we want it to do. And then the next thing that we're going to do is we're going to check to see if there's any errors at this point. If there are no errors, we will continue. If there is an error, then we will move on, turn the cursor back on, and exit with a 1, which is an error code. We've discussed that in past videos. And then you get the next file, or exit display function, key press. This is just holding on and waiting for some input. We use the read command to move on there. That's all that does. So we're declaring functions at this point, which is just loading things for the system to do in the screen in memory. So this is where we have our first function here. Well, the first function is what we just went through. Second function is the help display, which is all gornied up because I have it so huge. And then execution is really quite simple. The first thing that it does is make sure that you didn't type help. If you typed help, then it would run the function that is show help, and then it would start displaying files. We're doing a for loop here. Da, 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 da. At some point we'll get really deep into scripting, and I'll explain what that is. So a for loop is going through all of the files that we type in to the command line one at a time. Then it's going back up here and it's grabbing this function that's called display right here, and it's running it. And then when it runs, it moves on to the next file on the list, and once it runs out of files, then it's done and it dumps out. And we get out of it with by pressing a key, and we return the cursor to the screen and we clear. So let's see this in action. Let's actually make it work so you guys can see what it does. And what did I do there? I forgot to run that in the background. So I'll just close that, which gives me my cursor back. See, now if I had done that this way, right, then I could have just clicked over here and started typing because it was running in the background. But because I forgot the ampersand, it's running in the foreground and I can't really do anything. So let's run show real quick and we'll just put a bunch of files in. First, let's look at files we can feed to it. Let's do show, and we're going to do test, and we'll do test2, and we're going to do let's see, we'll do sorted, and if I could spell it right, it'll work. Okay. Sorted. And let's do folded as well. That's a giant file. I know. Should be pretty cool to see. So the first file that it displays is our name list that we did. Well, actually, no, we're at the bottom here. This is file 1. It's our unsorted file. And now we're going to go to the next file by clicking space. Space again. Now we have our sorted file. And now we have this big long file, which unfortunately will scroll all the way up the screen. But that's okay. Usually when you set this up for displaying files, you make them purposefully small in one screen. The idea is to create like a presentation that you can put on in a folder. And now it says it's out of files, and then it exits. That's it. That's show. So that's a little script that I wrote to do videos like this. I hope you enjoyed this video. If you have any comments or suggestions, or you see that I made mistakes, feel free to get into the comments and let me know. I would love to hear from you. I'm sure that people will point out all of the misspellings and all of the little problems, because they usually do. It's engagement. It's okay. Have fun. Point at the screen and laugh all you want to. What would you like me to do next? Let me know. Send me an idea. Put it in a comment. Your input is invaluable for keeping this channel going. Most of the videos that I've done since I started doing videos full time a little while back have been viewer suggested. So make a suggestion. We'll do it again soon.